We're all swimming in data these days, right? And it is so easy to get fooled by a flashy headline or a big number. But what if you had a secret toolkit to see right through the nonsense? Well, that's exactly what we're doing today. We are going to become statistics detectives and learn how to spot bad data.
All right, let's dive right in with our first case file. Check this out. It's an ad from a tutoring agency, and it claims that over 90% of its students got the absolute top grade on their university entrance exams. Sounds incredible, right? I mean, who wouldn't want to sign up? It's basically promising you a miracle.
But hold on. A good detective never takes things at face value. So what questions should we be asking here before we just believe this? To crack this case, we're going to look at 3 things. Who exactly are they talking about? How'd they even get these numbers? And what common tricks might they be using to make things look better than they are? Okay, first up, let's investigate the who. See, every statistic, every number is telling a story about a specific group of people, but the big question is, are we getting the full picture or just the one cherry-picked chapter they want us to read? So, in the world of stats, the entire group we want to know something about is called the population. Think of it as, say, every single student in all of Hong Kong. That's the whole universe we're trying to study. But, trying to talk to every single one of them, that's pretty much impossible. So what do researchers do? They take a small slice of that big group, and that's called a sample. The whole idea is that this little group can represent the whole population and give us a pretty good idea of what's going on. Now, this is where it gets really important. Getting from that huge population down to a small sample is the most critical part. What you're aiming for is what's called a representative sample. It's got to be like a perfect, tiny mirror of the whole group. Because if you mess this step up, everything else you conclude is just built on quicksand. So you might be thinking, hang on, why bother with samples at all? Why not just ask everybody? Well, that's called a census. And yeah, it's super thorough, but it's just not always possible, or even a good idea. There are some really good reasons why. First off, it can be crazy impractical. Like, imagine trying to poll every single person in a country. It would take forever and cost a fortune. And get this, sometimes testing actually destroys the thing you're testing. Think about car crash tests. You can't crash every single car to prove they're safe, right? You'd have nothing left to sell. And that's exactly why samples are so essential. Okay, so we've covered the who. Now our investigation takes a turn. We need to look at the how. The way you collect the data is every bit as important as who you're collecting it from. And when it comes to sampling, there are basically 2 ways to go. You've got the good way, probability sampling, where pretty much everyone in the population has a fair shot at being chosen. It's random, it's fair. And then you've got the risky way, non-probability sampling. This is where you just pick people based on what's easy, like grabbing the first 20 people you see at a mall. The problem? You could end up with a totally biased sample that doesn't represent anyone but those 20 people. So let's look at a few of these good probability-based methods. There's simple random, which is literally like pulling names out of a hat. Super simple, but can be a bit of a hassle. Then there's systematic sampling, where you pick, say, every 10th person from a list. It's really efficient and spreads things out nicely. And stratified sampling is really clever. You divide your population into smaller groups first, like by age or gender, and then sample from each group. This makes sure your sample is perfectly balanced. They all have their ups and downs, but the goal for all of them is fairness. But, the how isn't just about who you pick. It's also about the questions you ask. I mean, just look at this question. Do you disagree that people under 18 are not suitable to learn driving? My brain hurts just trying to figure that out. That double negative makes it so confusing. Answering yes or no is a total shot in the dark, which means the data you get is, well, it's garbage. But look how easy the fix is. You just rephrase it to be direct. Do you think that people under 18 are suitable to learn driving? See? Boom. Simple. Clear. And the answers you get will actually mean something. Always remember that. Bad questions lead to bad data. Period. Okay, so we've looked at the subjects and the methods. Now it's time for the really fun part, the final piece of our detective work. Let's uncover some of the most common tricks people use to twist the truth with numbers. Check out this classic example. It says over 91% of candidates passed literature and English, so therefore it must be an easy subject. Sounds pretty logical at first glance, doesn't it? But here's the kicker. That amazing 91% pass rate, it came from a group of just 244 students. That's a tiny, tiny fraction of all the students who took exams.
You absolutely cannot make a huge claim like it's an easy subject based on such a small and likely very specific group of people. That's the trick, using a tiny sample to make a giant, flashy, and totally misleading headline.
All right, here's another trick that gets almost everyone. It's the sneaky difference between percentages and percentage points. So let's imagine a university's admissions rate was 50% last year, and this year it's up to 60%. So how big was that increase? Is it a 10% increase, or is it an increase of 10 times percentage points? I know, they sound almost the same, but trust me, they mean two completely different things. Let's break it down. The simple difference between 60 and 50 is 10. So the rate increased by 10 percentage points. That's the absolute change. But what's the increase relative to where it started? Well, a 10-point jump from a starting point of 50 is actually a 20% increase. See the difference? People love to mix these up to make a change sound way bigger or way smaller than it really is. So what's the big takeaway from all this? The good news is you do not need to be a math genius to spot this stuff. All you need is a good detective's toolkit and just a little bit of healthy skepticism. And here it is, your official detective checklist. Anytime you see a number or a statistic thrown at you, just run it through these 3 questions. First, who are they talking about? Was the sample big enough? And more importantly, does it actually look like the larger group it's supposed to represent? Second, how did they ask? Were the questions confusing or biased in some way? And finally, what's the real story here? Are they using a tiny sample size? Are they playing games with percentages? Dig a little deeper. Because at the end of the day, you have to remember that numbers aren't just facts, they're stories. And the person telling you that story has a reason for it. But now, you've got the tools to be your own detective, to see past the flashy headlines, and to decide for yourself if it's a story that's actually true.